Hello, welcome to my video defense. I hope everything will be clear for you. I wish you a good day and good mood. Let's begin. In the first section of the video, I'll talk about Java in general. The Java language is closely related to the C++ language, which in turn is a direct descendant of the C language. Many features of the Java language are inherited from both of these languages. Java inherits its syntax from C, and many of its object-oriented properties have been carried from C++. In fact, a number of Java's defining characteristics have been carried over or developed in response to emerging needs from presenters. Moreover, the creation of the Java language is deeply rooted in the process of improvement and adaptation that has taken place in computer programming language over the past several decades. Therefore, in this section, we will look at the sequence of events and factors that led to the emergence of the Java language. As you will see, every innovation in the architecture of the language was due language that existed before, and Java is no exception in this regard. Java collections. The Java collection framework is a set of related classes and interfaces that implement commonly used data structures collections. It was designed and developed primarily by Joshua Bloch, and also it's a framework. It has no obvious critical sections of the code. The source isn't listed in 1981, and it works like a library. If we talk about array list, the array list class represents a generic collection that inherits its functionality from the abstract list class and uses the list interface. In simple terms, array list is a simple list, similar to an array except that the number of elements it's in not fixed. And here you can see a list has the following constructors: creates an empty list, creates a list to which all the elements of the call collection are added, and creates a list that has an initial capacity. And here the array list object is typed by the string class, so the list will only store strings. Since the array list class uses the collection E interface, we can use the methods of this interface to manipulate objects in the list. Also, we can freely add additional object to the array list object. Unlike an array, in reality, array list uses an array to store objects, and by default, this array is intended for 10 objects. If much more is added during the program, a new array is created that can contain the entire quantity. In a linked list, items are actually links in the same chain. Each element, in addition to the data that it stores, has a link to the previous and next element. These links allow to you navigate from one element to another. And all work with linked lists comes down to changing links. This can be seen very clearly in this example for adding an element to the middle of the list. Next, the hash set. The hash set class implements in the set interface is based on a hash table and is also maintained using a hash map instance. In a hash set, the elements are not ordered. There is no guarantee that the elements will be in the same order after a while. The operations of adding, deleting, and searching will be performed consists time provided that the hash function correctly distributes the items into the baskets, which we'll discuss later. A new informant points about hash set. Because the class implements in a set interface, it can only store unique values, can store null values, and the order in which elements are added is calculated using a hash code. Hashset also implements the serializable and clonable interfaces. The code below demonstrates some of the hashset methods. The generalist class treeSetE represents a data structure in the form of a tree, in which all objects are stored in ascending order. TreeSet inherits from abstract set and implements the navigatable set interface, and therefore the sorted interface. The following constructors are defined in the treeSet class. Create an empty tree. Create a tree to which adds all the elements of the collection call. Creates a tree to which it adds all the elements of the sorted set. Created an empty tree where all added elements will be subsequently sorted comparator. Next, hash map. Hash map is a data structure in the form of dictionary which each object has a unique key and some value. Inside the map that is stored in the key value format that is in pairs and any object number, strings, or object of other cases can act both as keys and values. There you can see the example for hash map. Tree map. Tree map is a tree-like data structure where each element has a unique key and some value. The arsenal methods of the tree map class allows you to invent solutions for every taste. Let's talk about UML. UML class diagram allows you to indicate the relationship between classes and their instances. What are they needed for? They are needed, for example, for modeling the application area. But how are relationship reflected in the code? This small study attempts to answer this question. To show this relationship in code, we have three main diagrams. There are case diagram, class diagram, object diagram. UML use case diagram. A use case diagram is used to represent the dynamic behavior of a system. It encapsulates the system's functionality by incorporating use cases, actors, and their relationships. It models the tasks, services, and functions required by a system, subsystem of an application. It depicts the high-level functionality of a system and also tells how the user handles a system. Following are some rules that must be followed while drawing a use case diagram. A pertinent main full name should be assigned to the actor or use case system. The communication of an actor with a use case must be defined in an understandable way. Specified notations it will be use it as when required, and the most significant interaction should be represented among the multiple of interactions between the use case and actors. Following are some important tips that are to be kept in mind while drawing a use case diagram. First, a simple and complete use case diagram should be articulated, and use case diagram should represent the most significant interaction among the multiple interactions. At least one model of a system should be represented by the use case diagram. And the last, if the use case diagram is large and more complex, then it should be drawn more generalized. Class diagrams. A class diagram is a diagram used in designing and modeling software to describe classes and their relationships. Class diagrams enable us to model software in a high level of abstraction and without having to look at the source code. In a class diagram, we list all classes methods, including the constructors. Constructors are listed first and then all class methods. We also write the return type of a method in the class diagram. Next, object diagram. Object diagrams are dependent on the class diagram as they are derived from the class diagram. It represents an instance of a class diagram. The object help in portraying a static view in object-oriented system as a specific instance. And how to draw an object diagram. All the objects represented in the system should be examined before start drawing in the object diagram. Before creating the object diagram, the relation between the objects must be acknowledged, and the association or relationship among the entities must be cleared already. To represent the functionality of an object, a proper meaningful name should be assigned. The objects are to be examined to understand its functionality. And the following are the application arrays for the object diagram can be used. First, it's to build a prototype of a system. Second, to model complex data structures. Third, to perceive the system from a particle perspective. And fourth, reverse engineering. And now I want to show you my code of using quick sort sorting. And in the both picture there I wrote the code where matrix sorted by columns and rows. You can stop the video and see my code here, and I hope it's understandable. In this code, our quick sort works. Similar with things object-oriented, a containers is a class that organizes other objects. Common containers are binary trees, quicks, lists, and stacks. Java supplies three container classes with the JDK 102 relays: Java until hash table, Java until stack, and Java until vector. The Java container classes demonstrate some of the problems with containers, especially Kate containers and the non-Kate containers like stack and vector simply stuff object in and pull object out. The Kate container hash table uses a K object to locate a data object. For the keying function to now work, the K object must support a method hash code that returns a unique hash code for every object. Here I showed you some code for this theme, and here you can see the definitions for each container.